So now we will be discussing about impulse response. Impulse response, which is very important. Impulse response. The name itself tells us it is impulse response. That means the output of the system when the input is unit impulse signal. Okay, the response, the other name for the output of the system when the input signal is impulse signal. That means let us consider a system. So when the input is unit impulse signals, and you are already familiar with the standard signals, so delta of t. So this is unit impulse signal. So when the input to the system is unit impulse signal, and I am going to get some output, and output we are not representing with the y of t, but there is a reserved letter for that is h of t. So that is impulse response, where h represents the impulse response, and it is represented with the h of t, and this is very important, and the impulse response plays very important role to understand the behavior of the system. Okay, if you want to understand the behavior of the system, so the impulse response is very important. So, and once I know the impulse response of the system, that means here the impulse response, if you know the impulse response of the system, we can easily find the output of the system for any input. That means let us consider I have given some input x of t, and I would ask you to find what is the output. Okay, so if I give some x of t as the input, then what is the output? Once I know only the impulse response of the system. Okay, there is a very important relation between the input, output and the impulse response. That is very important. So y of t is equals to x of t convolved with h of t. Okay, and this star represents the convolution. So this is very important mathematical operation. When we perform the convolution between the input and the impulse response, and we can easily find the output. This is one way of getting the output. Okay, once if you know the impulse response, that is the only thing that we need to know. The impulse response is very important. Once I know the impulse response of the system, and I can easily find the output for any input. Input kaina manam output find cheyochu once I know the impulse response of the system. Okay, and let us consider, as you already know that what is impulse response, and let us consider an LTI system. And one thing you must remember, and if you want to get this relationship, that needs to be an LTI system. So this relation is valid. This relation is valid only for LTI systems. This relation is valid only for LTI systems. Okay, and what is LTI system? So that you need to know. So let us consider the LTI systems. LTI systems. Let us consider LTI system. What is an LTI system? Okay, a system is said to be linear time invariant system. LTI stands for linear time invariant system. LTI means linear time invariant system. When the system is both linear and time invariant. Okay, when the system is satisfying both properties, that means linear, that means it is linear, the system is linear, and as well as time invariant, linear and time invariant. If the system is linear and time invariant, then the system is said to be LTI system. So on the other hand, you will be having LTV systems. That means linear time variant systems. Linear time variant systems. Okay, linear time variant systems. Linear time variants, it is satisfying the property of linearity, linear, and it is time variant. It is time variant. Okay, linear and as well as, and it is not time invariant, it is time variant. That kind of systems are said to be linear time variant systems. But anyhow, we will be mostly concentrating on linear time invariant systems. Okay, only on LTI systems but not on the LTV systems. Okay, coming to the linear time invariant systems, let us consider an LTI system. If the system is LTI, if the system is an LTI system, if the system is an LTI system, linear time invariant system, and when the input is x of t and the output is y of t. Okay, the impulse response of the LTI system, let us represent that as a h of t. Okay, now the relation between the input, if it is an LTI system, the relationship between the input, output and the impulse response is given by y of t is equals to x of t convolved with h of t. Okay, this convolution operation can only be done only when the system is LTI. It is not valid for linear time variant system. Why? Because we have derived this equation earlier using the property of LTI systems. That's why, and this star symbol is nothing but called as convolution. So the output y of t is equals to x of t convolved with h of t. This convolution is very, very important. If you want to find the output of the system, the only thing that I need to know is the impulse response. So what is the system output when the input signal is impulse signal వచ్చినప్పుడు ఏం రెస్పాన్స్ వస్తుంది, that is impulse response. ఇది ఒక్కటి తెలిస్తే చాలు. Once if you know this impulse response, then you can easily find the output of the system for any input. It can be any input by using the mathematical operation called as convolution. This is convolution. That's the importance of convolution. Okay, next we will move on to the transfer function of the system, and we will be discussing more about this unit number 3.